In the last video, I had introduced charging by rubbing, and in this video I would like to go into a bit more detail about how, or rather what happens during charging by rubbing. So a bit of the history behind charging by rubbing. When you take two substances or two items or two materials and you rub them against one another, then you are actually expending energy to overcome the force of friction between the two items. Then you are expending your own energy, and that energy is being provided to the valence electrons of a particular atom or a few atoms in a material, and that energy is helping it to become ionized, which leads to overall charge in the body. So now that those few atoms have lost a few electrons, so where do the electrons go? Where do the lost electrons go? So let's take a typical example that is shown in almost all physics labs, which is rubbing a glass rod with a piece of wool. A glass rod with a piece of wool. So, on rubbing a glass rod with a piece of wool, we are actually expending our own energy to overcome the force of friction, and that energy is being used to ionize a few atoms in the glass rod, which leads to overall charge in the body. So the glass rod is actually losing electrons. It's losing electrons, and that is why the atoms of the glass rod become positive ions, and this leads to positive charge in the glass rod. The thing to note is that since glass is an insulator, the charge which is created is not spread throughout the body of the glass rod, but it stays only where the rubbing has taken place. So that is what is static charge. It stays where it is. It does not move around. And now that I have ionized a few atoms of this glass rod by rubbing it with the piece of wool, so the electrons which have been lost by the atoms of this glass rod have been transferred to the atoms of the piece of wool, making the piece of wool negatively charged. So the glass rod becomes positively charged and the piece of wool becomes negatively charged. But this is a very common experiment, and this I'm explaining, and while explaining I'm showing it to you. I'm telling you that the glass rod will be positive and the piece of wool will be negative. In lower classes you have learned that this is a convention. This is a convention that the glass rod will always be positively charged and the piece of wool will always be negatively charged. However, this statement right here is not fully correct. There is a lot of theory behind why the glass rod is positively charged and why the piece of wool is negatively charged. For example, if I give you two very different items and I tell you to charge both of them by rubbing. So you rub one against the other, and then you hand the two items to me, saying that here you go, both the items are charged. But then I can ask you something else. I can ask you, can you tell me which item is charged in which way? Like, is this item positively charged, or is this item positively charged? Or which one is positively charged and which one is negatively charged? So in that kind of situation, how do I know whether an item is positively charged or negatively charged when I'm rubbing them? To understand that, we will need to understand something which is known as the triboelectric series. The triboelectric series. Just a brief history about the triboelectric series. The triboelectric series consists of items or materials arranged sequentially on the basis of their work function. I'm going to introduce work function in a completely different topic, but for now this kind of definition will suffice. So it consists of materials arranged sequentially, and the items which are present on the top of the triboelectric series, they, when rubbed with items which are present at the bottom of the triboelectric series, the top items will get positively charged. And the second item, which we have taken from the bottom of the series, will get negatively charged. So now let me show you the triboelectric series. This is the triboelectric series. This is not the total or the full triboelectric series, but just a part of it, just a few items, so that I can explain to you how this actually works. So if you look closely, then you can see that glass is located here. Let me draw it by some other color. I can see that glass is located here if you look closely. And if I look for wool, then I can find it here. So glass is present at the top. It is higher up in the triboelectric series than wool. So when glass and wool are rubbed against one another, then the glass rod becomes positively charged and the piece of wool becomes negatively charged. Similarly, if I take rabbit fur and glass, rabbit fur is located here. So if I take rabbit fur and glass and I rub them both together, then the rabbit fur will become positively charged. The rabbit fur will become positively charged. And the glass in that case will become negatively charged. Glass will become negatively charged. So if you look at the entire triboelectric series, then you can find out some really good combinations of producing charge. For example, if I take human hands and silicone rubber, the greater the separation between two items in the triboelectric series. Human hands are present at the top of the triboelectric series and silicone rubber is present at the bottom of the triboelectric series. So if I rub my own hands with silicone rubber, then the magnitude of charge produced will be very great on either substance. Human hands will be charged positively, and that will be a lot of positive charge. And silicone rubber will be charged negatively, and that will be a lot of negative charge. So the greater the separation between two items in the triboelectric series, the greater is the magnitude of charge on the items. That is a very important thing to know. So let me write it down. The greater the separation between two items in the triboelectric series, the greater is the magnitude of charge on either body. And the body which is higher up is positively charged, and the body which is lower down is negatively charged. Those are the only two things to remember. Thank you very much. That's all for this video.